Here at EV Pros, about 15 to 20% of our projects, if you will, are replacing or replacement of either faulty installations, bad wire size, or actually the biggest challenge we have are breakers melting down or plugs themselves actually melting, and then that affects the mobile connector or that extension cord that Tesla gives you. So if you take a look here on the table, what you'll notice is this is a brand that we don't necessarily recommend. It's either a Leviton or a Cooper. It's hard to tell because it's been melted so badly. And one of the prongs or the hot lines has melted. Here's the backside, what it looks like. So we don't want to have this situation in your home. This is a NEMA 1450, but this is a residential grade, so it's meant for intermittent use, something like an oven, let's say. Let's compare that, even just in physical size, you can tell the radii of the brand we don't recommend compared to the NEMA 1450, and it's the model number 9450A by Hubbell. Looks like this. It's a much more industrial grade product, and so even the backside you can tell, just comparatively speaking, even from a lateral perspective, it's a much more industrial grade receptacle. So price difference, $6, it's about $107. So be aware of that. Next is, and don't be fooled by, this is another one we had this last week. From the front, looks like no issues at all. In fact, if you read it correctly, and the Hubbell's upside down right now. So if you read it, this one actually says Hubbell as well. This is not a 9450A. This is, again, their residential grade NEMA 1450 outlet. So the configuration looks the same, but as you can tell, it's a completely different animal. This one is only meant for intermittent use. And you can see from the backside, you've got your two hots, a neutral and a ground. And believe it or not, the ground wires overheated not because there's current going through them, but because the heat that was coming off of one of these grounds actually caused that one to melt. So that was a challenge. And then finally, these are the result of wires that went to a wall connector. These are number 2 THHN, normally rated at 75 degrees. They're rated at about, I think 110 amps. Even those melted, and they melted because they weren't torqued to manufacturer specifications. So the entire insulation melted off of this one, almost causing a fire, and of course it ruined the wall connector. Finally, I want to point out one last thing. We talked about breakers. Someone actually used, this is a brand new Eaton breaker. It's a good quality manufacturer. In order to make it fit in the panel, because it wasn't going to fit on what we call the bus bar, that's what it clips into, they broke, and you can see how this shattered out here. They broke that plastic off intentionally and tried to shove this and force its way onto the bus bar itself. We obviously saw this because the breaker was sitting a little bit proud. It wasn't quite sitting flush inside the panel. So we were called out. We noticed it wasn't getting good connectivity. We removed this breaker, put in a full-size breaker that has just the 2 breakers on it instead of having 4 total breaker handles. It had just 2, or here they join the handles because it's a 2-pole system. And then we relocated that breaker to another position. So that way it could breathe better. We never want to put this on what we call a quad breaker. In so doing, it doesn't allow the circuits to breathe. It can result in some overheating in this area, especially now since they've compromised the UL listing of this manufacturer's listing on this breaker itself. So again, when you call EV Pros, it's not so much that we're doing a job any differently in the sense of, in the end product, you're still going to get a NEMA 1450 installed or a wall connector installed, but it's how we go about doing what we do that makes all the difference in the world. Thanks so much for watching.